Hey everybody, I'm Lex.
And I'm Austin.
PDQ.com.
That's right.
Today we're going to be talking about Minecraft.
Today we're playing Minecraft for a whole 30 minutes, I
30
believe.
minutes of Minecraft?
Yeah.
I'm going to destroy stuff and you're going to destroy stuff. Just kidding,
Correct.
guys. Didn't want to get your hopes up. We're talking networking.
That's right. Even better than Minecraft. The kids love it.
Is it really? I mean, we're talking, what, spanning tree?
Yeah, we're talking spanning tree. So, no, it's not better than Minecraft. And if you talk about networking in front of your kids, they'll go to sleep. So,
Well, guaranteed, because I need to put my kids to sleep a lot. They just like, I want to stay up.
I will give you the outline. You can take it home and start reading it, and they'll fall asleep.
Maybe I'll just play the video.
Yeah, there you go. That works too.
Where do we go? Where do we go and talk to spanning tree?
So last time when we talked about networking, we talked about like layer 2 fundamentals, like VLANs and trunking. So that's kind of, spanning tree comes off of that a little bit. So if you don't know what spanning tree is, it's basically an algorithm that a switch runs to verify a loop-free topology. And when we're talking a loop-free topology, we're talking something that we'll have to break down Ethernet real quick.
So, okay, a loop-free topology, right? We're talking about, okay, so redundancy, right? Huge in IT, right?
Correct, yeah.
Switch one goes down. I don't want to have to rely only on that. There's no single point of failure.
You're
so
right.
to do that, we've got to make things redundant.
Let's say somebody's walking around with scissors and trips and falls and cuts a cable. I don't know.
That's how it works, huh?
Yeah,
Okay.
just automatic. But so Ethernet doesn't have a TTL like IP does. And when I say TTL, time to live, if let's say you have a loop in your routing and a packet ends up getting thrown in that loop, eventually it will die. It has a TTL. Usually it's 128.255. I'm sure you've seen it if you've ever done a ping.
How do you keep that in your mental Rolodex, man?
It's because I talk about it all the time. I go home and talk about it to my dog. I try to anybody who will listen.
So network topology, can you show us what that would look like in regards to how that loop would happen?
Yeah, of course.
Okay.
So if we can look at this screen here real quick, you can see that we've got switch 1, switch 2, and switch 3 here. Let me just scoot these real quick. There's a little hidden circle over
You want my
there.
head behind? Okay.
So this is what, if we were taking a Cisco test or whatever, they would say, what is a topology supposed to look like? In this case, we've got a collapsed core here, right? Where switch 1 is what you call the leader of this building, let's say. And then you've got 2 access switches, switch 2 and switch 3. And right now we have a loop-free topology. Those lines in the middle represent Ethernet connections.
So physical cables, actually.
Correct, yeah.
Okay.
Yeah. So what spanning tree does is if you do something like this, let's say somebody accidentally connects switch 2 and switch 3 together. This is an Ethernet loop. You can get things like broadcast storms or ARP storms or however you want to define it. But the point is that if a broadcast packet is sent on this network and spanning tree didn't exist, eventually some bad stuff would happen. And let's go into that a little more.
Eventually, it's pretty almost instantaneous. It's fast.
Yes, when I say eventually, I'm talking nano milliseconds. It gets bad real quick. So let's dive into this. I'm going to create 2 little lines with squares on the side to represent some clients real
So
quick.
my computer, your computer.
Yep. Let's
Okay.
say my computer and your computer in this building. So if my computer over here were to send an ARP packet for your computer, we're going to assume they're all in the same broadcast
So
domain.
when you say ARP packet, we're just talking data, just simple data transmission, right?
Yeah, what we want to specifically talk about are broadcasts because of how switches perform actions on those broadcasts, right?
Okay.
I'm going to just scoot this one more time so my big head isn't in the way.
All right.
There's a secret little circle there. We'll go ahead and scoot. So when I'm talking spanning tree loop, let's say an ARP request happens, which is by default a broadcast packet, right?
Okay.
On a Ethernet broadcast domain. So if my computer sends an ARP request, the switch will receive it on this interface. My bad. So it comes in on this interface, nothing crazy there. But what the switch says is, okay, I've received a broadcast frame. What I'm going to do is send that out of every port except the one I received it on. And what we're going to do is just follow one path. But what would happen is one packet would leave here, one packet would leave here, right? That one ARP request now has been split 2 times over to switch 1 and switch 3. We're going to follow the switch 1 path. Switch 1 sees that, says, okay, I just got a broadcast on this interface. I'm going to go ahead and send it out every interface that I have attached except the one that I received it on, right? So this packet would follow this path right here. Oh, that's a terrible arrow. I'm so sorry. We'll go ahead and fix that. So the switch 3, same thing. It receives that packet. It says, okay, I'm going to send this out of every interface except the one I received it on. So your client gets it, and then it comes back this way. And I'm going to go ahead and, not do that. So sorry. So sorry.
Okay, so basically, I've now received it, but it's also been transmitted back to switch 2 again.
It has, yes. So what's going to happen is switch 2 is going to receive it on this interface one more time, and it's going to say, okay, I'm going to send this out of every interface except the one I received it on, right? So now you've received your packet once more, and then it goes right back out this way. And now we see the cyclical nature, right?
Yeah.
The loop.
Now, as it does this, right, I mean, there's more than one port on a switch, so it's broadcasting a ton.
Yeah, any connected port within the same VLAN, like we said, we talked about how VLAN segment broadcast domains. So if we're assuming this is all one VLAN, and this is just one packet, and this will be cycled over and over again. But yes, for every interface attached to the same VLAN, if you were to have a spanning tree loop, this one packet would repeat itself over and over again, and we're talking nanoseconds.
It'd be like exponential. It's like, boom.
Well, yeah, I mean, we're not even talking about the other way it went, where switch 2 shot it over to switch 3, and then up to switch 1, and then back to yourself, and that's just one packet.
So what does this do to traffic?
This, you could have 100 gig links, and this would cap out your traffic so hard. Your switches would probably turn off, or you would notice severe degradation to your network in terms of quality. Like, you probably wouldn't be able to connect to things. It would be it would be almost so instantaneous.
It would cripple you, right?
It would. It's a crippling effect.
Hence spanning tree, right?
Correct. So what a bunch of big brain smart people did was decide that this is not a good thing to have on your network. So by default, any good switch will have spanning tree enabled. And when I say spanning tree, what happens, and we're gonna kind of show off something a little more realistic, because most people don't create topologies like this. What they end up doing is something like this, where you have dual redundant links like that from switch 2 to switch 1. You do have a spanning tree loop between switch 1 and switch 2 if without spanning tree, right? Spanning tree needs to be performed and ports need to be blocked here. But we're just going to stick to this little triangle topology because it's
Keep it kind of simple. So, so spanning tree, right? It's going to prevent that loop from
Yes, it's going to prevent broadcast storms from happening by telling the switch, or the switch tells itself to block a port in this topology and logically making one of these links invaluable.
Okay,
right?
So how does that logic work?
So the first thing that needs to happen is an interface or a switch needs to be picked as the root switch. So what I'm saying is that for this spanning tree topology, it's like a tree. You got to have the base of the tree, right? So the way this works is that a root election happens. All these switches are sending what are called BPDUs out with their bridge priority and MAC address, their base MAC address. Every switch has a base MAC address attached to the system motherboard. But what the switches do is they calculate who is in charge here, right? Based off of those priorities. Now, a lot of, and I'm talking Cisco switches come by default with a static bridge priority. And what you want to do is try to avoid that. So let's say some genius brain came in this network and set this guy to 0, and then default. Sorry. So the reason that switch 1 would be set to default, or 0, excuse me, is because the lower priority wins in terms of root election, right? So, or excuse me, the lower bridge ID wins in root election.
So switch 1 in this case would be the boss. It would be telling everybody this is where.
Correct.
Okay.
And I want to emphasize that during spanning tree, the spanning tree process, no packets are flowing. I don't know if you've ever plugged an interface or a cable into a switch and noticed that nothing's happening for a good 30 seconds, right? Mm-hmm. what happens there is these spanning tree steps are happening. You cannot send packets during this phase of spanning tree election and port designation and all that good stuff.
Okay, so default, right? Let's just talk about the first time I ever set up a network. Multiple switches, right?
Yeah.
I plugged them in, boom, 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 boom. I didn't go change spanning tree. How did it determine?
So let's say these are all default. Let's
Okay.
go ahead and let's remove this 0.
Because I mean, I'm sure a lot of us have done that, right? I mean, you just plug it in. Let's rock and roll.
Yeah, if you aren't aware of your spanning tree topology, it's super easy to do something like this, right? So what happens is every switch, if your priority is set the same, its lowest MAC address wins, right? So in this case, when I write the letter here next to the switch, we're gonna assume that the MAC address is all A's in that case, right? In this case, we're gonna assume it's all B. In this case, we're gonna assume it's all C.
Do me a favor, change that A to make it D.
Okay.
Because you don't get to determine what the MAC address is. So
No, you
let's
don't.
say number one, you wanted it to be the main switch, right? Your root switch.
Yeah.
But it's all D's, B's, C's, right? So in this case, the way it's set up, which one is going to be designated as the?
So let's go ahead and do it. They all have default priorities, and based off their MAC addresses, we can see who is going to become the root bridge in this topology. So if its lowest MAC address wins, and we've got switch 3 here with all B's, it's definitely that guy.
The switch 3.
Correct.
And if you're hanging your internet and stuff off of switch 1, it becomes very inefficient at that point.
It does, yeah. So let's go ahead and do the port elections, and then we'll talk about why that's inefficient in this case. So what switch 3 is going to do is set all of its ports to designated. What that means is they will be forwarding. There's no blocking happening. It's good to go. So we'll go ahead and draw a little D for designated. All right, now it's between switch 1 and switch 2 to decide, okay, which of our ports are we going to block to get this loop mitigated, right?
Okay.
So what every non-root switch does is to elect a root port, right? So what this switch 1 is going to do, and it's easy. If they're directly connected like this, it's just the fastest path to the root switch. And we're going to assume these are all the same speed of Ethernet, all that good stuff. So we're going to say R for root port. All right, now we have this link right here that we have to decide what to do with, right? So what switch 2 and switch 1 are going to see is that, okay, my MAC address, or switch 1 is going to say my MAC address is lower than my neighbor switch 2. So I'm going to go ahead and block this port. We're not talking, it doesn't turn the port off. It just doesn't allow forwarding of packets through that port, right? And then this switch over here will set this as a designated port, which means switch 2 will send packets to switch 1, but switch 1 will not receive them. It's in a blocked state, right?
And that mitigates the loop.
Right. So what this looks like as a topology, or what this looks like logically, is that this port doesn't exist now, right? And to go off what you were talking about a little earlier, which is if that you have your, let's say, router hanging off of here, and then you've got your cloud over here. We're going to call.
I'm glad you draw like I do, man.
I draw terribly. I am so sorry.
No, it's great. I love it. It's like I feel, very at home seeing this.
Yeah. So let's say this is all completed now, and my client down here wants to send a packet to Google, right? Logically, it's going to look the same. Let's assume that the default gateway exists right here. If you were to trace route, it would look like nothing had changed, right? It's all one hop away. But what's actually happening is that packet or that frame is moving through switch 2 to switch 1, or to switch 3 to switch 1, and then out, right? This is not what I would call an efficient design. Now your switch 2 is reliant on switch 3. And let's say switch 3 is just a basic catalyst switch, whereas switch 1 is a nice distribution switch, has a bunch of UPSs on it, because it would be your building's distribution point, right?
Yeah. So you're saying basically because I didn't go in and set that switch 1 as the designated.
Because the bridge ID was not was left as default, you left it to chance, right?
Okay.
Or it is left to chance at that point who's in charge here. So if you have the opportunity to go into your networking devices, you definitely want to make sure that it follows a topology. I would recommend opening some diagram, even Paint, like I have here, and drawing out your network, all the physical links. And then if you have the ability to get into your switches, verify that root ports are facing the path of least resistance, I would almost call it, to the internet, right?
Shortest path, basically, right?
Yeah, for sure. So what you'd want to do is, what we would do in this scenario is set switch 1. I'm going to set its bridge priority to 0. You don't necessarily want to do that because maybe one day your topology may change, and you can't go any lower than 0 for the priority. So I believe it increments by, it's what I like to call a computer number. It's some exponential number that increases. And you can look it up on your switching documentation on how to do that for sure. But be cognizant of what your bridge priority is for VLAN. Therefore, you have control over the path like this, right?
So in this case, if you were to do that, right? I mean, if I'm catching you, right? In this case, the connection that would be blocked for spanning tree would be between switch 2 and switch 3, because switch 1.
It would, yeah. So this would come back up. I'm going to see if I can delete that. So this would come back up. One of these two switches would decide who's going to block their port. We're going to skip the root port election. It's in this diagram, it's pretty obvious where your root port's going to be. But in this case, lowest MAC address loses, right? So switch 2 will block this port right here, therefore mitigating the loop, right? And now you have what I would call proper layer 2 flow or layer 2 design.
Let me ask you a question. Would it make sense to go on a sign bridge to the other two, or just the initial route?
I would be wary of what your vendor sets the bridge priority to, and then keep all your core, or in this case, if your switch 1, or if you have a switch 1 in a building or in a layer 2 segment, just be aware of what the default is and just set it lower. That's what I like to do.
Okay.
That way I'm not going into every switch and setting bridge priorities. If you really want to do it though, just anything that's not supposed to be a root switch, go ahead and throw it all the way up to the top, as high as that number will go. It's all up to you. But what I would definitely recommend is make sure that flow is upward, and try not to go in, try not to de-optimize your network as much as possible.
You just don't want to add any more extra hardware in there, right? If you don't have to.
Correct, yeah.
So in this case, right, I mean, we got from your machine, the green line was going from switch 2 to switch 3, 1, and then out. Now we've optimized this, and it should flow.
It should, yeah. So in this design, it would flow like this. Please go away.
Please go away. Are you talking to me or
No, that little thing. So I drew through the 0 there, but it still stands. The flow is correct for what I would say this topology is, right?
Yeah.
But like I said, you're not going to get a lot of this. If you were looking at this as maybe a map, and switch 1 was in some core building, and you were somehow spanning VLANs across fiber links like this, then yeah, you would get something like this. But like I was saying before, where you're definitely going to see spanning tree implemented is if you have something like this. You have redundant links.
To each your switches, yeah.
Correct.
Should we take a question?
Yeah, let's go ahead and take a question.
All right, dear Lex and Austin, how often do spanning tree elections take place, or what would it take to start a new election? Sincerely, Kathleen F.
Yeah, let's jump into it. So I didn't
Time out. I'm going to let you answer that one.
Okay. So BPDUs are sent out every 2 seconds. So let's say that this spanning tree topology is stable, and we went ahead and plugged a new switch in here somehow, some way. Some Joe Schmo just went and plugged in a switch. That is switch 4. I am so sorry that looks terrible. But what happens is that if let's say by miracle we had set this to 1 instead of 0. It can't be set to 1, but I don't remember the actual values. They are exponential, so it's hard to remember the exact number at this point. But in this
Conceptually,
scenario,
though, yeah.
Conceptually, let's say it's 1, right?
Okay.
And then somebody came in and some goofball was a network genius accidentally and set his switch to the bridge priority of 0, right? As soon as switch 1 receives that Bpdu, and because it's happening every 2 seconds, the spanning tree will change immediately. Switch 1 will set all of its ports to designated, except the port that faces the now newly elected root switch. Switch 2 and switch 3, nothing changes because to get to switch 4, they have to go to switch 1, so they'll elect those links as root port.
So the nice thing is, Kathleen goes in, she makes the change within 2 seconds.
Yes.
The tree should take care of itself.
So you want to, and like Josh is saying in the chat, what you want to do is avoid any Bpdu elections or Bpdus to be sent on your interfaces. Now, we're going to start getting into a little Cisco, and I wanted to...
I got to ask you a question because Bpdu.
Yeah, Bridge Protocol Data Unit.
Okay, thank
So
you.
it's like PDU, like you would see in what they would call an entire packet, and then they just slap bridge on top of it.
Okay.
Network engineers, they got big brains. They
There are
just
a lot
slapping
of
things on.
acronyms.
Big brain on Austin.
It is a lot of acronyms. I agree. So Bpdu Guard is just an idea where if switch 4 were connected to switch 1, you as the network person or as the sysad would want to be aware, you want control over your paths to other switches. So on anything that isn't consciously set as an interface towards a switch, you would set what's called Bpdu Guard in Cisco world. What happens is when the Bpdu comes in to switch 1, let's say Bpdu Guard is set on this interface here. When the Bpdu is sent, boop, it's blocked right here. And then the switch says, I wasn't expecting Bpdus on this port because I wasn't expecting a switch to be here. I'm going to block this port. In Cisco world, it's error disabled by default, and there's no more traffic that can happen here.
So no traffic.
Yeah, that if you have Bpdu Guard enabled and it's triggered, you can consider it a malicious attempt, right?
All right. Good to know. Good to know.
Yeah, we've had experience here with Bpdu Guard. I'm not going to mention any names, Josh, but if you end up plugging in switches and you create a spanning tree loop, the switch will recognize that that's a Bpdu, or it's received its own Bpdu. If let's say you plug in a little Netgear switch that doesn't do spanning tree, and you somehow loop your network back into itself, the Bpdu is forwarded out of the Netgear switch back into itself, and then the switch recognizes, hey, I got a Bpdu here, I wasn't supposed to, and it blocks the port, thus killing anyone who was connected to that little Netgear switch internet.
I got a funny story. I actually went one time and I was looking at, the guy's like, my network's down, right? And you go help him out and you go in the closet and you're like, how many computers you got? I'm like 4. Got a 24 port switch and they're all plugged in. Well, I didn't want the data to fall out, so I plugged, the dude, he plugged them all in.
Hey, I'd rather have the data fall out than have the data recycle itself just consistently.
And the funny thing is it happens a lot. I mean, it's, especially when you start getting into networking the spaghetti of wires.
Even the best network engineers accidentally loop themselves back into their switch. You just want to be aware that, just be conscious of spanning tree, be conscious of why it takes forever for a switch port to come up, because these things need to happen to prevent any mistakes that anyone has made, or maybe yourself. But
we've all done it.
Yeah, I've done it. I've done it.
The master has done it. Wow.
Hey, the master was once a little Padawan, and he's definitely created spanning tree.
Too true. Do we have any questions?
Sure, why not? Hey guys, for switch 1 to 2, using multiple lines for redundancy, is there a benefit to using spanning tree instead of lag? Sincerely, Matthew C.
Okay, so now when I like to talk about networking, we're going to add a layer to this cake. Spanning tree, what happens with link aggregation is that the switch combines those 2 ports into one logical port. So at that point, spanning tree only sees it as one interface, although it's 2 physical cables, and then spanning tree can perform over one link, right? So that's where link aggregation is definitely important when it comes to spanning tree.
Where would you use link aggregation mostly?
When you're doing something like I've got on the left here, where you've got 2 physical cables going to one switch, if you left it alone, spanning tree would block a port, and you wouldn't get that redundancy. I mean, if one interface were to suddenly go down, the other one would begin forwarding.
So link aggregation is like another lane on the highway.
Correct. Yeah,
Okay.
you could call it that. What it does, just to touch on link aggregation, it definitely doesn't double bandwidth. It just there's an equation that the switch runs to determine based on this source and destination. I'm going to send it down this interface, and it tries to load balance it as best as possible. So technically, if these are 2 gigabit Ethernet interfaces, you have 2 gigabits of Ethernet, but your one traffic flow is still going to only have 1 gigabit available to it. If I'm making any sense here, but
There's just no rush hour.
there is
Less rush hour, maybe.
correct,
Okay.
yeah. So yeah, link aggregation is definitely important, and spanning tree still plays a role, but you want to make sure that you have some link aggregation protocol running on, like I have here, these parallel links, if you want to use your connections to their best ability. So in Cisco world, it's called an ether channel, but other vendors call it different things.
Yeah.
Just make sure you read up on that. We'll definitely touch more on this. I'm not sure if,
You're running a series, right?
yeah, I'm definitely running a series. It's a networking series about all sorts of networking goodness. You guys are basically getting a
Tell me, networking goodness?
networking greatness.
Greatness.
It's,
There you go.
it's
Okay.
delicious. Mwah. But so you guys are definitely getting a sneak peek. These are more freeform study groups, I would almost call it.
Yeah.
Whereas these videos are more outlined, and they have labs and all that good stuff that we can go through.
In fact, you did the first video that was published yesterday.
I did,
right?
yeah. Go check it out on our YouTube channel. We've done our first one. If you've seen the first webcast, it was basically the same, except we went into a lot more detail because I had a lot more. I made a lot more structure for myself. So,
Do we got more questions?
We have a couple.
A couple, okay.
Dose. 2.
Deuce.
Guys, can you share a networking story where you spent hours to find a problem and at the end it was something really stupid? Marcel.
We all got those.
do you want me to?
You tell yours, I'll tell mine.
Okay. So, I was deployed in the Middle East. It was late. We were working 12-hour shifts, and I'm making a new switch. So I had one switch up on one terminal, the aggregation switch, and then I had the new switch I was working on. And they were both on the same screen. So to get EIGRP up, a routing protocol, I looked at the information it had on one side, or the information that I wanted to supply this aggregation switch, and I thought I was typing to the new switch, and I typed in to the old switch, or the aggregation switch, a command called Eigrp Stub, I believe. What happens is if a switch or if a router is designated as a stub, it basically stops advertising routes. So you've got 100 routers connected to this distribution switch, and now they've all lost routes back up to the distribution switch. And this is mid 2019. I think there was a lot of drama in the Middle East. So this was a bad time, and I took down flight lines. I took down the entire west side of the base on accident because I was in the wrong terminal. And it took me so long to figure out what I did because I had to go comb through the distribution switch because we're receiving phone calls. It's me and one other person. It's late at night. And they're like, we're down. And I'm sweating bullets. And eventually I found that I had just copied and pasted a config into the wrong switch. So
It happens.
yeah,
And
super classic.
You know, mine's embarrassing because we actually talked about it. I plugged in switch 4.
Oh, did you really?
I plugged in switch 4, yeah. So, and again, it was like, as soon as I plugged it in, it started having issues, right? So again, mine was like, okay, we'll just back off what we did. And then again, it was just the designation. I didn't have mine designated.
Yeah, yeah. Spanning tree and being conscious of where you...
It's easy. It is so easy to do. It's like you don't even have to think about it. Like boom, boom, I'm rocking and rolling.
Yeah, and it's super easy to prepare yourself. Like when you create a network, if you just set switch 1 in our scenario to a low bridge priority, you never have to think about it again. You never have to think about it again. But it just takes one mishap or one if you don't know.
Old switch you plugged in that was a primary switch that actually had a lower designation.
Exactly, yeah.
Boom.
Never plug in a switch that used to be used into your network unless you want some major issues. If you want to look up some horror stories, we don't talk about BTP here because I don't use it. I mean, there's no point in it. But VTP spanning tree. Never plug in an old U switch unless you've wiped the config.
Oh, yeah. Too true. Want to do another question, or should we move on?
Well, we have one question remaining.
Okay.
I do believe it's more of a deploy question, but if you'd like, we could take it.
Should we do it?
Yeah.
Let's do it.
All right. How can I target computers in nested groups? Example. Computer is member of role group. Role group is member of my app group. Deploy my app group to all members of my app group. Sincerely, Jeremy, who spoke in class today.
Are you?
I mean, that's kind of like, okay, so there's some level of inception there now.
Okay.
I'm just trying to, target computers nested group.
So are they Active Directory groups? Like, is this a group nested within a group in Active Directory?
So kind of that's where I'm thinking I'm going with this, right? So role group, member of an app group, deploy app, all members of my app group. Boy, I'm kind of stumped on that. Jordan, thoughts?
Well, if it is what we're thinking, where it's an Active Directory group within Active, you can, with PowerShell and ours can see groups like that, or you can create a collection based on group membership.
See, now that would be my thought is you do build a collection based off group membership, but yeah, I'm going to say build a collection based off group membership. That's probably the best route to go. Anything you want to add to that, Jordan?
He said he's updating the chat. He's talking 80 groups. So if it is 80 groups, our products can use those to filter out either through a collection or by deployment. You can specify the group.
Sweet.
I'm going to go with what he said.
Sounds good. I see Hugh's question here. So some devices, when you connect them, they do.
Probably should read it, man.
You know, I'll read it for you. I
you will?
recently connected a something antenna, which has an IP address, and I received Bpdu messages and port shuts down. It is not a switch, but an antenna. Is spanning tree thinking it is a loop?
So when we say switch, we think a 48 port 1U device, right? But a switch basically just forwards frames, right? This antenna takes a wireless technology and then translates that into wired Ethernet and forwards that, right? I assume there is a switch inside this device. And when I say switch, something that has switching logic, right? So the creator of this antenna probably is running some switch software that does send BPDUs out that interface. And it will trigger Bpdu Guard or whatever you have on your interfaces to shut that port down. What I would do is verify that interface. If this is a thing that you're conscious of and you want it in your topology, just make sure that Bpdu Guard is turned off in this case, so that way that interface is allowed to turn on and forward correctly, and then you should be good to go. If you are the sysad and you're plugging in anything that has that is sending Bpdu guards, you are conscious of that decision and you're accepting that will be there. Therefore, you can remove Bpdu guard. What Bpdu guard does, or in this case, it just it prevents people. I don't want to say people who don't know what they're doing, but people who just plug things in from destroying your network without. If you're going to destroy a network, you have to know that you're doing it at least. So
yeah. No accidental destruction.
That's right. That's right. You have to have a conscious decision to destroy it. So
Daryl in the chat says that if it is the antenna he's thinking of, it uses ubiquity bullet access points, which would hit the...
Exactly. Yeah. A lot of these vendors are using protocols like LLDP and Bpdu because they're industry standards. You're supposed to be using them. Mm-hmm. Whenever you're forwarding packets like this, they by design have to have these things. So for your case, Hugh, I would just make sure that you don't have any Bpdu prevention mechanisms on that interface, so that way it's allowed to come up. And if any, I mean, it doesn't sound like there's a loop there because it's from the switch to a antenna. You're not going to get a spanning tree loop. And if you do, just make sure PoreFast isn't enabled. Super quick, what PoreFast does is just immediately put the state of the interface into forwarding. It skips the entire spanning tree process, which is a bad thing if you end up accidentally creating a spanning tree loop. So you have to be conscious about what you're configuring on what interface, but hopefully that helps. So
nice. We have a question.
We do. We have another.
What if I don't want to take it?
It's too bad, man.
I'm going to ask Austin. Do you want to take
Probably
a
should ask
question?
Austin
I can
anyways.
take a question. Yeah.
Okay. Well, this one is for you, dear Austin and not Lex. What is your preferred method for load distribution when using port channels? Thank you in advance, Jonathan.
What is my preferred method for load distribution when using port channels? So what comes to mind is you're either talking about the protocol, like LACP or PAGP, if we're in Cisco land.
Okay, before we go too far into all these acronyms, you're going to be shooting videos on a lot of this stuff.
I will, yeah. If we want to talk about load balancing, I would love to talk about that in our video. Feel free to catch up on that in the next coming weeks. To
answer that, though, yeah.
to come off of what Lex is saying, I'm going to put a pin in that, and we're going to reference that in a video in the future. That way we can kind of tackle your question. But if you're talking either the protocol or what calculation do I prefer with the switches, I prefer LACP, and then I let the switch by default. It has, I think, source and destination IP and MAC that it uses to calculate which port it goes through. I hope that's what we're talking about. If not, feel free to clarify for me. But sweet.
Dude, I love the fact you're making videos on this.
Yeah.
I have learned so much just, doing these with you and that. So
It's great because months ago I was just talking to my dog and cat about networking. They don't care, right? So now I can
they
sit
can
here
talk
and,
to me.
I can talk to you, and I can sit there and go on rants for 10, 20 minutes, and everyone pretends like they care, and that's what matters the most.
In fact, we may need to push routing to another day, I think.
Yeah, we're
Do we
definitely
need
going
to
have
push
to.
routing?
Yeah.
Okay.
Yeah.
Yeah, we're
I
definitely
do
going to
have
have
a
to.
quick question if we have time for that. You mentioned when the switch first plugs in, there's 30 seconds of dead time, but then it sends out the Bpdu every 2 seconds. I guess if there's nothing found, is it just bypassing, there's no downtime at all, or is it just constant downtime every 2 seconds that we have to account for?
So the BPDU is sent every 2 seconds, right? But the switch will sit and try to listen for BPDUs for upwards of 30 seconds, right? So you're not going to get any traffic flow if you don't have port fast enabled for, I believe it's 30 to 45 seconds with typical spanning tree. There is, I'm forgetting the acronym. I know, crazy.
Oh, come on.
Rapid spanning tree, thank you. Rapid spanning tree does reduce that time, I think, to 5, 10, 15 seconds. But yeah, you're going to have downtime if you have spanning tree enabled without port fast on every interface that is ever connected to that. Whether it faces a host or it faces a switch, the switch is going to try to listen for BPDUs during that period.
I figured 30 seconds is not bad to not take your network down.
That's true. If you like your network, I think 30 seconds is a fair time. Or if you want to enable Bpdu Guard or with port fast, you've got that. There are plenty of options, and you should reference your vendor's documentation for those options for sure.
All right, guys.
So spanning tree, we'll hit routing another day.
Yeah,
You got a video series.
I do. Yep. First one's out. Second one should be coming out.
We're shooting
What's
that
the
today.
second one on?
The second one's going to be on what we talked about last time, which I think was VLANs and trunking. But we're just going to go into more depth with that.
So you can get the details, the deep dives
Yes.
on the videos.
Yep.
We appreciate you guys watching. I'm Lex,
And I'm Austin.
pdq.com.
We'll see you.
Thanks for joining our webcast today. Congratulations, Jonathan S. and Hugh L., winners of PDQ swag. Please send us your info at webcast@pdq.com. And please take some time to like and subscribe to our YouTube page. Thanks again for joining us, and we'll see you back here next time.